Hello everyone and welcome back to Fritz and Lab blog. Today we're going to talk about Raspberry Pi Pico 2 with the chip RP2350 and microPython. We are going to program it with microPython. I'm going to show you a few tricks, a few things you can do to control GPIOs, to read buttons and to control LEDs or some kind of load like that, with GPIOs. So first thing I want to show you is the pinout of the Raspberry Pi Pico 2. This is it. It has 40 pins total, of which 28 are GPIO, are general purpose input and output. Other pins are GNDs, VCCs, 3v3, 5 volts, USB voltage, and this kind of things. There's also one LED on GPIO 25 or pin 25, which we are not going to be using today. We're going to be using an LED on GP16, which is on the bottom right of the image. So GP16 is going to be, it's going to be a push button, and then GP15 now, GP15 on the bottom left is going to be one LED, one green LED that we're going to use. We're going to implement a sketch that in microPython that controls the LED, controls the blinking of the LED. If you press the push button once, it's going to start blinking the LED. If you push the push button again, it's going to stop blinking. It's going to go 1 or 0. It's going to stay at the last state available, but it's going to stop blinking. Then when you press the push button a third time, it's going to start blinking again. Let's go to the code. As usual, I use Tony IDE, which is a free software specifically for microPython, right? It's very lightweight. It doesn't have a lot of functions, but it's okay for what we're going to be using in here. Let me just show you one thing in here. This was in Portuguese. Let me put this in English. LED state changed. Okay. And then instead of clicks, okay? This is more English now, okay? Yeah, so let me show you first what this code does. This is the sketch. This one is the LED, okay? And then there's one push button. I'm gonna press the push button. Oh, let me first go to run, okay? Yeah, now we're running. I'm gonna press the push button, so it's blinking. Is it blinking? It stops blinking. Now it's blinking again, okay? The LED is blinking. Now it stopped because I pressed the button. Blinking again. So when I press the button once, it starts blinking. When I press again, it stops blinking. Let's have a look at the code, okay? So first I import the machine module and then the time module. I'm gonna need the machine module for GPIO, inputs and outputs, time module for the time ticks, the function that I use to take control of the time, okay? Then I do LED. Let me just do one thing. Botão, I'm gonna substitute by button. Replace all, okay? So I have button machine pin 16 input. So pin 16 is gonna be one input and pin 15 is gonna be one output. Tempo LED. Tempo LED is gonna be LED time. Place all, okay. Contagem is gonna be counting. Ligar LED. LED on. Estado anterior. Last state, okay. Replace all. Acionou button is gonna be button on, and then clicks. It's more like English now, okay? So what's happening here? On LED time, I'm gonna store the time.ticks of the present millisecond. This millisecond in the code is gonna be stored on LED time, okay? Button Oh, let me just tempo button time. Okay. So yeah, button time is gonna start the millisecond right now as well. While true, so this function always executes because nobody's telling it to go false, so it's always true, so it's always executing. It's a loop, okay? Uh, Now I have two if statements in here, one and then two. The first if statement is for the LED, so for it to blink every 200 milliseconds, to change state every 200 milliseconds. So I do LED.value, not LED value. So I read the LED value, do not, or I negate the LED value, and then I feed that to the LED value. So the previous LED value is going to be different from the actual or the current LED value, okay? This is the LED blinking function. Um, the second function in here is also a difference between the current time ticks millisecond and then button time. But I do this every 20 milliseconds. This is for reading the button, okay? So I read the button essentially every 20 milliseconds. If button value is equal to 1 and last state is equal to 0, so if the button is pressed and was not pressed before, I do my magic, okay? I do print LED state changes. I print clicks plus str clicks, so I get the number of clicks, convert to a string, and then concatenate with the word clicks, okay? Um, then I have a protection for the number of times, or for the bouncing actually, for the number of times I can read the button on and off. It happens every 20 times 20 milliseconds, so 400 milliseconds. So I only read the button every 400 milliseconds. It prevents the button to be bounced, or the button to bounce around, okay? So this is it, like every 400 milliseconds happens one read of the button, essentially. Okay, when it's read, it takes another 400 milliseconds to read again. This is the most important part of the code. LED on is equal to true. If LED on is equal to true, it means we can blink, we can change the state of the LED. If LED on is not equal to true, we cannot blink. We are not going to be blinking. So this if decides whether we are going to be blinking or not, okay, based on the LED on equals to true. You want to see this again? So yeah, this is the circuit. I'm going to press the button. See, the LED is blinking. Press the button again. The LED is not blinking. Guys, if you want to have more information about this, the full code, actually, the full microPython code, which is a main.py file, is going to be available at fritzenlab.net. Again, fritzenlab.net, 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 for you to take, okay? And see you guys in the next videos.